Hello guys, what's up? The sky is up. How are you all of you? I hope all of you are doing very well. As usual, all of you are doing always very well, isn't it? I'm asking you actually about your studies. How is it going on? I'm sure it's going on very good. So today, let's get straight to the point. We will be doing the last and the final exercise of chapter 4, exercise 4.6, which is very important for a big 6-mark question. Okay, so this exercise it's very easy because so far we have already learned what is a matrix, how to find out the determinant of a matrix, how do we calculate the minors, how do we calculate the adjoint, the cofactors. We have done almost everything, so this will be just like icing on the cake. Okay, so you are going to like this exercise, and on top of that, it guarantees 6 marks at least. So this is really going to be helpful for you. So get your pen, book, paper, water, whatever be it, everything ready. Sit tight. Let's wait for a moment or two for your friends also to join us, and we shall begin very soon. So till then, if you have still not subscribed, please do subscribe and give me a like also if you haven't liked the video. So let me see how many of you are. Imsisanla, good evening. Imtisana, good evening. Imnimongla, Saktiala, good evening. Lono, good evening. Bendang Allari, good evening. Biha, Lanila, Mernala, Alamnongla, Beast Boy, good evening. Imsotila, Shiponla, Menangangla, Imnasanla, Chuatula, Imsanongla, Asanla, Sangita, Utimongla, Ashley, Kimikali, Sangjami, Priyanshu, Sentiaran, Suponamla, Lance, Santi, Lumtur, Avila, Maung, Song. Good evening, a very good evening to all of you. Today I think most of you are here, many of you are here. Last class, I think some of you are not there. So, chalo, it's good to see that many of you are joining also again. So, yeah, as a flashback, from okay, Hilal, you're also there, so good evening, Hilal. As a flashback from the previous exercise, I think today Sanjami, Hilal, these are some students who missed out the last class, so it's good to have you back again into our small, cute family. As a flashback of the previous exercise about invertible matrices, these are some of the theorems which you might just need for multiple choice questions also. So you can just have a go through it. All right. And yeah, Chukazumla, good evening. I have a news for all of you, that is, I'll be very soon starting a crash course of JEE mathematics course also. Very soon, maybe in a week or two, I'll be starting that. So you can stay tuned. You can start preparing for your JEE mathematics paper also. So I'll be very soon starting that series also. Plus, of course, I'll be starting another special series on shortcut tricks on mathematics, on how we solve, and that's really going to be helpful for, of course, our multiple choice competitive examinations and many other examinations. It will be used for all examinations, bank examinations, even in engineering examinations also it will be useful. So I'll be starting that series very soon, so please stay tuned, share as much as possible. Chubamanla, good evening. So I think that's enough talk done. Shall we rock and roll? Alright, so let's begin with today's session. So as I've given you some of the theorems, I hope you've written it down. I'll just wait for a few seconds again. Okay, you can write it down. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, boom. Chalo, let's begin. So these were some theorems based on invertible matrices. You might just need that for multiple choice questions and so on. Okay. But today our main concern is solving. Today our topic is this: solving a system of linear equations using matrix method. Solving a system of linear equations by matrix method or using matrix method. Alright, so this is our topic today. This is application of determinants, application of matrices only, application based questions. Now if you remember in class 9, 10 and all, we have solved linear pairs of equations, pairs of linear equations. In up to class 11 also we have solved, if you remember, some of the methods were like substitution methods, cross multiplication methods, equating the coefficient method, where we are given a pair of linear equations and then we solve them by any of these methods, and then we find out the values of the variables x, y and z, and that's the solution done. Okay, Punchman, okay, good evening, a very good evening to all of you. So this guy is also new. So Romson, good evening. So good to see many of you are joining and then wishing. It's very nice. Okay, it's very nice to see each and every one of you. So now in class 12 we are going to learn another method which is also useful. It can be used according to our convenience, depending on the conditions. So we will be learning how to solve this pair of linear equations. But this time, of course, it can be utilized not only for a pair of linear equations, maybe 3 equations given to you, linear equations given to you, 4 linear equations given to you. So using matrix method also, we can solve equations. All right. So that's what we are going to be learning here now. Now, Im Chinba, good evening. So now what happens here is, before we really begin, before we really continue to solve the system of linear equations, what we also know is that every system of equations that are given, a pair or a set of 3, it's not necessary that they will always have a solution. You know that, isn't it? You've done it in class 10 also. There are 3 conditions basically that comes. The 3 conditions are the UNIQUE. For example, a pair of linear equations, ax plus by equal to c, a1x plus b1y equal to c1, a2x plus b2y equal to c2. So this pair of linear equations either can have a unique solution, can have infinitely many solution, or they can have no solution. So this will be a universal problem every time we are given, sets of linear equations. So every time we start with a pair sets of linear equations, this is going to be our problem, because it's not necessary that every time the set of linear equations are given to you will have always unique solutions. We know that we can only solve for unique solutions. We cannot solve for infinitely many solutions. We cannot solve for no solution, because there is no solution also, isn't it? So if there is no solution, no solution. So even this also has to be taken care, and this also will be taken care in matrix by the matrix method. But before that, these 2 sets, we call them as consistent, isn't it? See, consistent. Consistent equations means if you have a set of equations which have either at least 1 or more solutions, then those set of equations will be called or are said to be consistent. And no solution means inconsistent. Alright, so we will deal with this problem first. Okay? We will be dealing with this problem first. How do we deal with this problem? But before we really deal with that problem, let's see. Let's consider a set of linear equations. Let's say a1x, b1y, c1 equal to 0. a2x, b2y, c2 equal to 0. a3x, b3y plus c3 equal to 0. So let's consider a set of 3 equations given as this. Then, if A is assumed to be the set of the coefficients of the variables and the constant term, let's say, no, 3 equations means you will have 3 variables. So in that case, we'll have to write C1z, C2z, C3z is equal to not 0. Let's say D1, D2, D3, the constant. Nah? Because if you have a pair of linear equations, two variables, we're talking of set of three linear equations, so we'll talk of three variables. So A2, B2, C2, A3, B3, C3. And X represents the matrix of the variables. B represents the matrix comprised of the constant terms, D2, D3. So again, if you have this set of linear equations, then if this set of linear equations can be written in the matrix form where A represents the coefficients of the variables, X represents the variables, B represents the matrix of the constants containing the constant terms, then what happens is this system of equations, you already know how to multiply matrices, isn't it? Multiplication of matrices. Then as per by matrix method, this system of equations actually can be also represented as Ax is equal to B. If A is considered as a set of the terms containing the coefficients of the variables, X as the variables, B as the constant terms. B as the constant terms. Then this set of equations can be written in the matrix form as Ax equal to B. A represents a matrix of 3 by 3, X represents a matrix of 3 by 1, B represents a matrix of again 3 by 1. Then we can represent this equation. We have to do it in matrix method, remember. So in that case, Ax equal to B. Alright. Will our regular classes resume after the second week of June? I don't think so. I don't think that's possible. Okay, because situations are not getting any better. So I don't think that even if the lockdown may end, I think schools will be the last option. So maybe I think, this is just my gut feeling only. Most probably I think your schools may resume maybe at the earliest, maybe by July. At the earliest, I'm saying July. I don't see any, I don't think people will be taking the risk for letting students go to school, at least in the month of July, June, I guess. Maybe after that, if the curve flattens out, then maybe after that, by July, slim chances. I'll be more confident to say that your schools might resume from August. But from July, yeah, slim chances are there. Slim chances, okay. Timsamallah, good evening. So that's what I feel, but we do not know. So anyway, so this is how a system of equations given to you would look like in the matrix form. Alright, now the case is this. I hope you're noting it down. Case 1. Case 1, that is when the determinant of the matrix A is not equal to 0. If you remember, this was non-singular. When the determinant, that means you will find out the determinant of the matrix A. Alright, and if the value of the determinant of the matrix A is non-singular, then in that case, what will happen is the system of equations will have a unique solution. The system of equations will have a unique solution, and of course it will be consistent. It will be consistent. Unique solution, it will be consistent. And of course in that case A inverse also will exist. So that means it will have a unique solution, and that is where we will be now using the concept of matrix to solve the system of equations, that is to find out the variables x, y and z. How do we do that is simply this concept, Ax equal to B. Remember in the last class I told you about post multiplication by A inverse. Here what we will do is pre-multiply by A inverse. So A inverse A, that's I, X equal to A inverse of B. So X would be A inverse of B. So this is how we will be solving the system of linear equations if the set of linear equations given to us has a unique solution. That is X, which represents the set of the variables, not set, matrix of the variables, will be equal to A inverse of B. This is our key to the lock which will help us get 6 marks. Okay? Alright, done? Chalo. Then, of course, we still have to take care of those two conditions also again. I'm wrapping it up, okay? 5, 4, 3, 2, 1. So, of course, we still have to take care of the two conditions again. That is case 2. Case 2 is, for unique solution, done. If determinant of A is equal to 0, if determinant of A is equal to 0, then what do we do is, we will find out adjoint of the matrix A and multiply it with B. Then we will get 0. We have two conditions here. Again, when not equal to 0 already decided. Again, when this is equal to 0, then adjoint of A into B might not give us 0. So one case it might give us 0, one case it might not give us 0. When it will not give us 0, then we say that the system has no solutions. That is inconsistent. And in that case, in this case, what happens? Infinitely many solutions, but it will also be still consistent, because remember, consistency is a case where you have at least one or more solutions. So of course it will be consistent even though it cannot be solved. It will be consistent even though it cannot be solved, because it will have infinitely many solutions. Okay, ho gaya. So this is from where we shall begin. All right. So let's go to the exercise now. Chalo. Let us go to the exercise. So let's have a look at the exercise. Exercise 4.6. Exercise 4.6. What is the question there? First set. Examine the consistency of the system of equations. Examine the consistency of the system of equations in exercise 1 to 6. Number 1, x plus 2y is equal to 2. This we have only a pair. 2x plus 3y equal to 3. Now maybe equation 1 and equation 2. Maybe we'll just write equation 1 and equation 2. So what we can do here is let A be the matrix which consists of what? A will be the matrix containing these the matrix of the coefficients of the variables. So 1, 2, 2, 3. Got it? X, we have two variables, x, y. B, constants, 2, 3. Okay? Then the given system in matrix form can be written as now AX is equal to B. Of course, you can A into X, you multiply equal to B, you will get a system of equations only. Now to check consistency, let's first find out the determinant. Determinant of A. That is 1, 2, 2, 3. Remember, determinant when you write, don't write it like matrix again. Matrix and determinant, we know they are very different. So that's 3 ones are 3 minus 4. What do we get? Minus 1. That is equal, not equal to 0. Not equal to 0. So conclusion. What shall be the conclusion? Therefore, A is non-singular. So A inverse will exist. If A inverse exists and it will have a unique solution, then of course it is consistent. That's what we have to do here. These are just revision questions, basic questions. All right. Okay, we're going to skip questions again here also, number 3, because we have to save time, remember, right? So other simpler questions, I'm sure you will manage to do it, I'm very sure of that. 2x plus 6y is equal to 8. 2x plus 6y is equal to 8. So our matrix would be 1, 3, 2, 6, xy, 5, 8. The rest of the things will be same. So what is the value for determinant of our matrix? 6, 1, sorry. Let's find out the determinant. 2, 6. That is 6 minus 6 minus 6. That is, of course, what do we get? 0. So here, of course, the matrix A is singular. So A inverse, what happens? Does not exist. But will it be consistent? We can't say. Is it going to be consistent? We can't say. Because if you have noted down the previous points, you have seen that if it does not exist, then about its consistency and inconsistency, particularly now good evening, no good evening, if it's consistent or not consistent, then that we will get to know only after we find out the adjoint of the matrix A. So for adjoint of the matrix, let's find out the cofactors, A11, A12. That is minus of M11, M11 minus of M12. Okay, how much will be that? So M11, 6, M12 minus 2. And A21, A22, that's going to be minus of M21 and M22. So M21, 1 minus 3, M22, 1. So then our adjoint of the matrix A would be 6 minus 2 minus 3, 1, its transpose. So 6 minus 3 minus 2, 1. Now we will have to get the product of this matrix with the matrix B. So adjoint of A with the matrix B. 6 minus 3 minus 2, 1 into the matrix B, 5, 8. Definitely these are conformable. 2 by 2, 2 by 1. So resultant matrix will be a 2 by 1 matrix. So that might look like this. So A11, A11. So 6 5s are 30 minus 3 8s are 24. Next 2, 1. 2 5s are 10 plus 8. So our resultant matrix minus 4 minus 2. Sorry, 8 3s are 24. What? Today also started. So 6. 6 minus 2. So definitely what? This is not equal to 0. So whenever it's not equal to 0, what was the conclusion for us? When it's not equal to 0, what happens? They will represent parallel lines, so they would be inconsistent. Inconsistent. Alright, so that's how you will be getting things done. Alright, okay. So let's try some more again. Shall we try 5? Question number 5. So this time we have a 3 by 3 matrix. 3x minus y minus 2z is equal to 2. 2y minus z is equal to minus 1. 3x minus 5y is equal to 3. So let our matrix A be 3 minus 1 minus 2, 0, 2 minus 1, 3 minus 5, 0. Matrix X, of course, X, Y, Z. And matrix B, constants, 2 minus 1, 3. I hope you can see. Now time to get our determinant A. So this is done. I'll be wrapping this because I need space. So let's find out the determinant of A. So that's 3 into 2 zeros are 0 minus 5 1 to 5 minus of minus 1 into, come on, what did I do? 3 into 2 zeros are 0, 5 minus 5 minus of minus 1 into 0 minus minus plus 3 minus plus minus 2 into 0 minus 6. So what do we get? 3 into minus 5 plus 1 into 3 minus 2 into minus 6 minus 15 plus 3 plus 2 6 are 12. What do we get? 12 plus 3 15, that is equal to 0. That means A is a singular matrix. So that means A inverse does not exist. So that means A inverse does not exist. A inverse does not exist. So then we have to again proceed now to, for a joint now, let's find out A11, A12, A13. So that's going to be M11 minus of M12 minus, M13. So that would be minus 5, minus 3, minus 6. A21, A22, A23. A21 will be minus of M21, A22, that will be M22, A23 minus of M23. How much will be that? M21, 2, 1, 1 0 is 0, minus 5 2s are 10. 1 0 is 0, minus 5 2s are 10, minus minus, okay, minus of minus 10, so that will be 10. M22. So you just remove this, 3 zeros are 0, minus minus plus 6, isn't it? 0, 0, 0, 6, and M23. You just remove this, 3 5s are 15, minus 15, minus minus plus 3, minus 12, minus of minus 12, that will be plus 12. You can check also. Then finally, M31. Sorry, A31 will be M31. A32 minus M32. A33 will be M33. Let's calculate. 3 1, 3 1. So if you minus 1 1. 1 minus minus 2 2s are 4 plus 4, that's going to be 5. M32. If we you just remove this, then this 3 ones are 3, minus 3, minus 3, that will be plus 3, and m3 3 twos are 6. That's it. Five, 3, 6. All right, so let's get the adjoint now then. So I don't need the matrix A anymore, I'll need B only. So adjoint of matrix A would be minus 5, minus 3, minus 10, 6, 12, 5, 3, 6 transpose. So that would be minus 5, minus 3, minus 6, 10, 6, 12, 5, 3, 6. Isn't it, folks? So then find out its adjoint with the product with B. Product with B. Product with B. 10, 6, 12. Product. I hope you're studying. Please remember, okay, study. Don't wait for schools to reopen. Don't wait. Your wait might be just very long. So prepare, because board exams, it doesn't matter whether board exams are conducted or not. That's not the whole point. It's about education. These days you see so many memes in social media where they try to, give us a picture of the effects of online education and all. So you see, that's what it means. So please, educate yourself. Okay, educate yourself. Train yourself. It's not about the marks also. It's about the knowledge. No? So 5 twos are 10, minus 10, plus 15. 3 twos are 6, minus 6, plus 9. 6 twos are 12, minus 12, plus 18. So 20, minus 5. 12, 6 minus 3. Minus 6. Minus 5, minus 3, minus 6. So here what do we get? Again, that is not equal to 0. So therefore, the system will have no solution. That is, it will be inconsistent. All right. Actually, this is what we will be doing in the next topic again. Again, from here only we are going to be proceeding. So it's kind of an exercise for us also. Okay. All right then. So time to move up to question number 7. Other questions, we can give it a try. It's going to be same. If it is, of course, if it is consistent, if the determinant of A is not equal to 0, then your job is done. Then it's very simple. You don't have to do anything else. But problems like this, when the determinant of A doesn't turn out to be 0, then yeah, then of course we have to continue. No? Okay. Number 7, that is, solve the system of linear equations using the matrix method. When they say matrix method, use it. Let's say number 7. 5x plus 2y is equal to 4. 7x plus 3y is equal to 5. So we have to solve here. So most probably the determinant should not be 0. But anyway, let's check. I'll write here. Let A be 5, 2, 7, 3. The matrix X, variables, X, Y. Matrix B, constants, 4, 5. The determinant of A, 2 by 2 is so nice, no? Very easy. Sorry, equal to 1, which is not equal to 0, so therefore A inverse will exist. So AX equal to B would imply X equal to A inverse of B. Alright, so that means we have to get A inverse and multiply it with the product, get the product with B, you'll get the value of X. So then let's find out A inverse. Now to find out A inverse, we will need the adjoint of the matrix. So for that, let's find out the cofactors. Alright, so M11, 2, M12, minus 7, M21, minus 2, M22, 5. So the adjoint of our matrix A would be 2, minus 7, minus 2, 5. Its transpose, that's going to be 2, minus 2, minus 7, 5. We don't have any 3 here. How? This is 3. All the terms should be present, no? 3 minus 2 minus 7, 5. So then what is our inverse? A inverse is 1 by determinant of A into adjoint of the matrix. So 1 by determinant of A is 1. So 1 by 1 into adjoint. 3 minus 2 minus 7, 5. Alright then, so we get our inverse of the matrix. So X is equal to A inverse of B. So A inverse 1 by 1, that's 1. 3 minus 2 minus 7, 5. B 4, 5. Got it? So I'm just going to do it here. So that's going to be 3 4s are 12 minus 5 2s are 10. 7 4s are 28 minus 25. And what is our x? xy. So xy is equal to 2 minus 3. So then from equality of matrices, what shall we have? And that implies x is equal to 2 and y is equal to minus 3. And that's how we solve. You see? That's how we solve. Now you can check your answers by substituting the values of x equal to 2 and y equal to minus 3 in any one of the equations. So 5 into 2 plus 2 into minus 3. What do we get? 5 to the 10 minus 6, 4. Exactly same. Exactly correct. Alright, so this is how you can use matrix method. But of course, yes, in a 2 by 2 matrix, when you have a pair of linear equations, definitely I would prefer substitution method, equating the coefficient method and all. But when they say matrix method, of course we have to do it by matrix method. But this method again will be helpful for you when you have a 3 by 3, 4 by 4 big matrices. Okay. So that is how we solve a system of linear equations by matrix method. That's how we call it solving. Alright, so fine then. Let's move on to now 3 by 3. 2 by 2 I think you can also manage. So now let's move on to a 3 by 3 matrix. 2x plus y plus z is equal to 1. X minus 2y minus z is equal to 3 by 2. 3y minus 5z is equal to 9. I'll just write here, let A is equal to, okay, so we are past the half an hour mark, so time to give me a hi, hello, how are you? Kisses, hugs, everything. So, you can start sending me your wishes. Give me a hi, hello, whatever. In the meantime, I'll just write on this so that we are not caught sleeping. Come on, come on. Come on, you can do it. Okay, oh yeah, Hilal, I like that. Mushi, mushi. Oh, guji, 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 guji. Oh, mushi, mushi, mushi. Hello, YOLO, yeah, konnichiwa. Okay, konnichiwa. Hi, sir. Hi, happy birthday. Oh, happy birthday. Someone's birthday or what? If someone's birthday, then wow, many happy returns of the day. May God bless you with more and more wisdom. Hello, hello, hi, Satyala, hi, hi, hi. Hello, hi, hello, hi, hi. Hola, hola, hola. Okay, hola, hola, hola. Mushi, mushi, hola. All right. Buji, buji. No? So cute. Okay. Alright, done. So, fine then. Time to get back to business now. Hello in Japanese. Okay. I thought you were saying cute, cute, cute. We call it, no, when we see small kids, you know, ah, mushy, mushy, she's so, what do we call it? Healthy. Oh, Imba, good evening. Long time no see, and then today, all out of nowhere, you're here. Good to see you. Alright, I'm learning a lot of Korean and Japanese languages in the process of teaching you matrices and mathematics. So actually, you see, I'm benefiting from you. So that's how we mutually benefit, isn't it? That's called sharing, right? So yeah, network issues. So it's really nice to learn from all of you, all these Japanese languages, and also today I've learned one. What Japanese language? So that's so nice again. All right. Anyway, let's get back to the business now. Determinant of A. So that's 2 into 2 5s are 10 minus minus plus 3 minus 1 into minus 5 plus minus 0 plus 1 into 3 minus 0. So that's like 2 into 13 minus 1 into minus 5 plus 1 into 3. 26 plus 5 plus 3. 26 means 30, 31, 32, 33, 34. That's again not equal to 0. Two, one minus 1 minus 2 minus 1. Doesn't matter. Ismail, good evening, Ismail. Good to see you after such a long time. Alright, so actually we could have solved that equation previously, but anyway, we'll just try. If it is wrong, it's okay. 10 minutes wasted, we'll go back and do it again. Anyway, so that is done. So therefore, what? A inverse exists. A inverse exists. So now time to find out the cofactors. That's 13 minus of minus 5, 3. So 13, 5, 3. A 2, 1. That is minus of M 2, 1. A 2, 2. That's M 2, 2. So minus of M 2, 1. Minus of M 2, 1. 2, 1. So minus 5, minus 3, minus 5, minus 3, minus 8, minus of minus 8. So that's plus 8. M2, 2. 2, 2. 2 5s are minus 10. A 2, M3 minus M23. A31 M31. A ones are minus 1 minus minus plus 2 1, isn't it? Minus 1 plus 2. M32 3 2. 2 ones are 2 minus 2 minus 1 minus 3 minus of minus 3. 2 ones are 2 minus 1, yeah, minus 3 3 3. 2 twos are 4 minus 1 minus 5. I hope I haven't made any mistake there. Let's check once again. 5 twos are 10 plus 3 13. M1 2 minus 5 plus 5. M1 3 3 ones are 3, no problem. M2 1 minus 5 minus 3 minus 8 minus minus plus 8. 2 2. 2 5s are minus 10, no problem there. M2 3 2 3 2 3s are 6 minus 0 minus 6, no problem. All right, that's it, I guess. Now I don't trust myself. I do a lot of careless mistakes. So anyway, so adjoint of A, 13 5 3. 8 minus 10 minus 6. 1 3 minus 5. It's transpose. So that will be 13 8 1 5 minus 10 3 3 minus 6 minus 5. So A inverse was 1 by determinant of A into adjoint of A. Can somebody tell me what was the determinant of A? I rubbed it off again. I'm very good in rubbing all this stuff. Can someone tell me? $34. All right, thank you. 34. So that's it. Time to find out X, A inverse of B. So 1 by 34. A inverse 13 8 1 5 minus 10 3 3 minus 6 minus 5 into B. 1 3 by 2 9. Actually, I should have simplified the second equation by cross multiplying by 2. That way we would have got a simpler equation. I didn't do that. But anyway, we can, but there might be a small problem with the multiplication. Fraction, I mean. Not problem, but just let's see. You have to be just careful, that's it. 13 ones are 13 plus 8 into 3 by 2. Like this. 8 into 3 by 2. 2 4s are 8, so 4 3s are 12 plus 9. That part, not that fraction multiplication part. Next, 5 ones are 5 minus 10 into 3 by 2. 2 5s are 10, so minus 15 plus 3 9s are 27. And lastly, 3 ones are 3 minus 2 3s are 6, 3 3s are 9, minus 45. So 1 by 34. So let's add them up and see. So how much will we get? 13 plus 12 plus 9. Okay, we get 34. This one, 27 plus 5. 32 minus 15. That's 17. And the other one, 45 plus 9 minus 3. minus 51. So that was here x, y, z. So again x, y, z is equal to 34 by 34, 17 by 34 minus 51 by 34. So that would be 1 by 2, 17 3s are 51, 17 2s are 32. 34 I mean. So x is 1, y is 1 by 2, z is minus 3 by 2. You have to be extremely careful. Okay, I'm the one who is telling you to be careful. So you have to be like extremely careful, okay, with this calculation, because one small mistake, everything is ruined. Your whole 6 mark done. So please try to be careful. I'll also try to be careful because I'm also very good in making mistakes. So let us all try to be careful. But the thing is that I'll not be losing 6 marks. You will be losing 6 marks. So that's the difference as of now. Okay, so you have to be very, very cautious and careful. So that's what we will be doing. So all the questions actually are same. All the questions will be done in the similar way only. Okay, nothing is going to be different. Alright, so you can give it a try. So let's now move on to 15. Because we'll be solving almost similar type of questions. So let's not repeat the questions again and again. So let's try 15. So the matrix A here is given. Because these are just practice questions only. So the other equations I think you can do. You just have to be careful. But because this also will be the same. Find A inverse. Using A inverse, solve the system of equations. So find A inverse. Using A inverse, solve the system of equations. So let's find out the determinant. 2 into minus 4 minus 4 minus of minus 3 into minus 3 into 3 2s are minus 6 minus minus plus 4 plus 5 into 3 1s are 3 minus 2. So that's like 2 into 0 plus 3 into minus 2 plus 5 into 1. So that's minus 6 plus 5 minus 1, which is definitely not equal to 0. So A inverse does exist. So time to get its factors, cofactors for A inverse. A12, A13, A21, A23, A22, A23, M11 minus M12, M13 minus M21, M22 minus M23. Let's calculate. This is 0 minus of minus 2, that's plus 2, M131, M21, 2, 1 minus, so 3 2s are 6 minus 5, again 1, 2 2 minus 4 minus 5 minus 9. This is fine, isn't it? 6, sorry, 3 2s are 6 minus 5, 1, 1 minus 1. And this one, 2 3, 2 1s are 2 minus minus plus 3, 2 plus 3, 5 minus 5. Alright, let's continue again with, okay, -1. Let's not forget the determinant of the given matrix, -1, -1, -1. I'll start from here again. M31, not M. A31, A32, A33. M31 minus M32, M33. And adjoint of the matrix A would be the matrix formed by this transpose. So this 3 4s are 12 minus 10, 2. This 2 4s are minus 8 minus 15. Minus 23. 23. And then lastly, 2 to the 4 plus 9, 13. So then 0, 2, 1, minus 1, minus 9, minus 5, 2, 23, 13. So this is 0, minus 1, 2, 2, minus 9, 23, 1, minus 5, 13. So this is a joint of A. So A inverse is 1 by determinant of A by a joint of A, that is 1 by minus 1 into 0, 2, 1, minus 1, minus 9, minus 5, 2, 23, 13. Two, three, 1. Okay, this is done. So the inverse, ultimately inverse of the given matrix -1, if you multiply 0, minus 2, minus 1. 1, 9, 5, minus 2, minus 23, minus 13. Please write it down so that I'll rub off all the other stuff which is not needed, just to create confusion for us only. Okay, now you look at the equation that is given to us. The equations are 2x minus 3y plus 5z is equal to 11. 3x plus 2y minus 4z is equal to minus 5. X plus y minus 2z is equal to minus 3. The question is, using A inverse, solve the following system of equations. Now, if you look at the following system of equations, determinant of, you see, 2 minus 3, 5. 2, what? Yeah, 2 minus 3, 5. 2 minus 3, 5. 3, 2 minus 4. 1, 1 minus 2. That means it's the same matrix, isn't it? If the matrix was slightly different, then yes, we may have to start everything all over again, but it's not the case. It's the same matrix. That means we can just use the same result, that is using AX is equal to B such that X equal to A inverse of B. That is, A inverse is 0, 1, minus 2. Minus 2, 9, minus 23, minus 1, 5, minus 13 into the matrix B that we can get from here, 11 minus 3. So let's get the values. So X is X, Y, Z, and this is 0, minus 5, minus minus plus 6. Next, minus 22, minus 45, minus 22, minus 45, minus minus plus 3 to the 6. Sorry, 3 3s are 9, 3 to the 6. Then again, minus 11, plus 25, minus 25, minus 25, plus 39. And that is 1, 67, 68, 69, 2, 25, 35, 36, 3. So that implies x is 1, y is 2, z is 3. Bingo. Mad angles. Alright. So that's how simple it is. So let us move on to question number 6. Not 6, sorry. 16. The question. The cost of 4 kg onion, 3 kg wheat, 2 kg rice is rupees 60. I wish it was that cheap. These days even 1 kg would cost you more than that. No, upay nahi. Maybe the book was written long time ago. The cost of 2 kg onion, 4 kg, 3 kg, 6 kg is rupees 90. This. Find cost of each item per kg by matrix method. By matrix method. By matrix method. Question number 16. Let rupees x, rupees y, rupees z be the cost of each kg of onion, wheat, rice, respectively. Then, as per the first case, 4 kg onion, 3 kg wheat, 2 kg rice, 60. Next, 2 kg onion, 4 kg wheat, 6 kg rice, 90. 6 kg onion, 2 kg wheat, 3 kg rice, 70. So we'll have to solve this by the matrix method. Chalo. So let A is equal to 4, 3, 2. So done. Finished? Okay. So I'm going to write it here so that I get enough space. Maybe here I'll write. So let A is equal to 4, 3, 2, 2, 4, 6, 6, 2, 3. Of course, X is X, Y, Z, and B is 60, 90, 70. I hope you're all excited because this is the last question of this unit 2. So I hope you have been studying well. I hope I was of some help to you, at least of some help to each and every one of you. I hope that I have done my part in sharing a little bit of the knowledge that I have generally. So I hope that you are at least not left blank. So please do let me know in the comment section below later on also because this is the last question. So I'm excited. I hope you're also all excited, and I hope that I have helped you with the little knowledge that I have to impart. Okay, so all right then. So that's it. Tell me something. If you have anything to let me know, you can please share. 4 3s are 12 minus 6 2s are 12 minus 3 into 2 3s are 6 minus 6 6 are 36 plus 2 into 2 2s are 4 minus 6 4s are 24. So that's 4 into 0 minus 3 into minus 30 plus 2 into minus 20. So that's 90 minus 40, so that's 15, which is not equal to 0. So A inverse shall exist. Thank you, Inky, all those sweet words. These kind of words really motivate us. It's good to know that some of you, of course, it's very helpful because these kind of words are very, very motivating. Okay, so to be honest, because it motivates us, and then when we are motivated, definitely we would also like to give you more and more, right? Thank you so much, each and every one of you, those who are acknowledging. I really appreciate that. Of course, this is just not the end, this is just the beginning, so definitely we are going to learn more and more, but it's kind of nice to see because, okay, 6 marks Pakka, sure, but mistakes are just lurking around the corner. Yes, I'll be the first one, of course, there. So, yes, but you know, it's when you see that students are cooperating and then you know there is a connection between the teacher and the student, we always like to give you more. Because if we are not motivated, then that's the time when we are also dejected. We are also humans. But when we get motivated by such beautiful students like you, then definitely, like you know, we tend to give you more and more. So it's really a pleasure teaching all of you guys. It's really has been my pleasure. Okay, so thank you so much. Thank you so much. Thank you each and every one of you. All right, let's go now to joint of A inverse exists. Let's go for now the cofactors and the minors. A12, A13, A21, A22, A23, M11, M12, M13, minus M12. Definitely, Hilal, thank you for that. Of course, because of our teacher, I guess your teacher really did a good job. So thank you so much. And yeah, of course, as I say, this is just the beginning. More to come. But I need your cooperation. Without that, it would be nothing. Two, three, 2, 3, 4, those are 8, minus 18, minus 10, so minus minus plus 10. So 3, 1, 3, 6 are 18, minus 8, 10, that's M32, M33, 4, 6 are 24, minus 4, minus 20, and lastly 4, 4 are 16, minus 6, 10. Minus 20, 10. All right. Imsinola, thank you so much. You never fail to inspire. It's, as I say, no, it's, this whole hard work is mainly because of you people only. I'm motivated, that's why. I'm motivated, that's the main thing. Of course, you hold the credit, okay, to everything that I've been doing. The whole credit actually goes to you because you did not fail even for a single day to motivate me. Those who have been regularly been with me, and that's the main reason. It's good to know that I motivate you to work hard because without hard work, nothing can be achieved. No matter what we are going through in life, we still have to remain fixed to our goal. Distractions will always come in life, but we cannot let those distractions, de-illusion us. Just make us lose our track. No. We have to be fixed. What is our goal should be our goal, no matter what happens. Good things, bad things. See, life is all about that. No, life is all about good things, bad things, coming, going out. We cannot be fluctuated, we cannot be moved around. That's why the tree, the bigger the tree, the stronger are its roots because its foundation is strong enough. And small trees and shrubs and all, what happens? They can be just blown away by wind because their roots are not strong enough. So our roots need to be very strong enough. Our foundation needs to be very strong enough. Our will, determination should be very strong enough. We will do. Kuribo. We have to do, I will do it, I'm going to do it. It's going to be difficult, but doesn't matter. That should be the attitude. And what was our determinant again? I forgot. 50. Sorry. Zero minus 5, 10, 30, 0. This is minus 20, sorry. Just make some correction there. 30, 0, minus 20. I made a small mistake there. So 0, 30, minus 20. So let's calculate 0 into 0 minus 450 plus 700. 1800 plus 0 minus 1400 minus 1200 plus 900 plus 700. So that's 1 by 50. So 450, 550, 650, 750. 450, 550, 650, 250 minus, that's 400, 16, that's again 400. 250, 400, 400. So that value x, y, z will be 5, 8, 8. So that implies x is 5, y is 8, z is 8. Therefore, cost of 1 kg of whatever base, what was that? The cost of 1 kg of 1 kg of 1 kg of. So what did we start with? 1 kg of onion, wheat, rice. So onion, right, rice, because I'm a bit hungry now. So always thinking of rice. Rupees 5, rupees 8, rupees 8. Maybe that's the reason, maybe. Rupees 5, rupees 8, rupees 8. Alright, so that's it. That's it for today. So that winds up our course, that winds up syllabus. I mean, not syllabus, sorry, not course also. The unit 2 finished. Alright, so that's the end of unit 2 for us. So I hope you've enjoyed the whole unit. I enjoyed it. So hope to see you soon again with the next unit. Let's see what we can start. So the next unit again, I'll hope to see all of you super excited like this. So till then, all of you, my dear students, take care, thank you, and yeah, sarangi. What do you call like? Okay, sarangi. No? Alright then, bye-bye, take care, and yes, do stay safe, wear your mask.